Hello, my name is Philipp Ruchti, and in this video I present our work Mapping with Dynamic-Object Probabilities Calculated from Single 3D Range Scans. In this work we tackle the problem of building a 3D grid map of the static aspects of a dynamic environment. The traditional approach to this problem filters out all measurements representing dynamic parts of the environment and uses only the remaining static parts to build the map. In contrast to this approach, we predict in the first step a per-point probability that this point is reflected by a dynamic object. In the second step, we add beams proportional to the probabilities into the map. In the lower part, we can see our pipeline. First, we take a 3D scan, transform it into 2D images. We then feed these images into our neural network to get the dynamic probabilities. In the second step, we then use these probabilities to build a 3D grid map. To predict the probability that a point is reflected by a dynamic object, we use a neural network. We first generate 2D images, such as range and intensity images, which we then feed into the network. We also test other modalities to fill the 2D images. The prediction runs on a single scan and therefore does not require odometry, IMU, or scan matching to translate consecutive scans. The result of the network is a per-point probability that this beam was reflected by a dynamic object. Our network is capable of detecting objects like parked cars that does not move in a dataset but can start moving at any time. We then use the predicted dynamic probabilities to build a 3D grid map, where each cell represents the probability that a beam is reflected by a static object. We therefore incorporate beams proportional to this probability into the map. Beams with a low dynamic probability increase the map value in the cell where the beam ends, while a high dynamic probability or beams passing through a cell reduces this value. As a result, we get a map where each cell represents the probability that the beam is reflected by a static object.